Welcome to the DEFCAM. Pakistan's acquisition of the Mirage 3 began in 1968 as part of a long-term strategy to secure a high-performance multi-role platform capable of operating in the regional environment. The Delta Wing fighter offered supersonic performance, effective radar-guided interception, and all-weather capability. The version acquired by Pakistan included modifications that made it suitable for regional operational profiles, including ground strike and high-altitude interception. Soon after, the Mirage 5 followed as a complementary platform, specifically configured for ground attack and tactical strike roles. It removed some of the more complex avionics to make room for more fuel, allowing extended low-level penetration missions deep into hostile territory. The synergy between the two aircraft types allowed the Air Force to build a doctrine around speed, precision, and survivability. As geopolitical developments, such as sanctions and shifting alliances, made sustained access to Western parts and upgrades difficult, Pakistan invested in indigenous capabilities to maintain and upgrade the fleet. This effort included localized parts manufacturing, avionics integration, and reverse engineering critical components. The establishment of a dedicated restoration and upgrade facility, the Mirage Rebuild Factory, marked a turning point. It enabled the systematic overhaul of airframes and the integration of new technologies that extended aircraft life well beyond original service expectations. The modernization strategy was embodied in a structured program that included digital cockpit installation, enhanced radar capability, and all-weather strike equipment. Under this initiative, the reconnaissance and air defense capabilities of the Mirage 3 were significantly enhanced. The Mirage 5, reconfigured for high-precision attack roles, was updated to integrate guided munitions, laser designators, and terrain-following radars. These changes allowed Pakistan to maintain frontline capability despite limited access to newer platforms. The Mirage 5 was also selected as the launch platform for long-range standoff weapons, including locally developed air-launched cruise missiles. These modifications involved structural changes to accommodate weapon carriage and delivery requirements. Navigation systems were reconfigured with global positioning and inertial aids, ensuring accurate targeting across hostile terrain. Electronic warfare compatibility was introduced through specialized pods, allowing survivability in contested environments. With the upgrades in place, these platforms were deployed during major periods of regional tension. Their roles included high-risk penetration, interdiction, and standoff strike, often from forward-deployed airbases in austere conditions. Their performance in these scenarios was enhanced by systematic pilot training in deep strike tactics, electronic warfare, and low-level ingress techniques. Data-sharing protocols and upgraded mission computers helped integrate these platforms into networked combat environments, which was a significant leap from their Cold War-era roots. The Mirage fleet also demonstrated resilience through environmental and combat stresses. Although crashes did occur, the causes were usually external factors like poor visibility, terrain, or technical failure due to extended operational life. Structural design integrity ensured that most such incidents had manageable outcomes. Lessons learned led to procedural refinements, better diagnostics, and more immersive simulator-based pilot preparation. To address attrition and maintain operational strength, Pakistan sourced surplus Mirage 3 and Mirage 5 airframes from multiple countries, including Australia, Libya, Spain, and Lebanon. These aircraft were either cannibalized for parts or upgraded and returned to flying status. The continuous replenishment cycle provided mission flexibility and minimized operational disruptions. These acquisitions formed the backbone of resource continuity and allowed experimentation with further capability enhancements. Mirage rebuild and support infrastructure in Pakistan evolved alongside the fleet. In-house fatigue testing and non-destructive inspection facilities were created to assess structural integrity. Composite material workshops and engine refurbishment centers were added, ensuring independence from foreign maintenance cycles. This transformation turned what was initially a support facility into an aerospace capability development hub, supporting aircraft longevity and adaptability. As more advanced fighters such as the JF-17 assumed primary air defense and strike roles, the Mirage fleet transitioned to strategic support tasks. These included nuclear delivery training, electronic warfare mission profiles, decoy deployment, and simulation of enemy strike packages. The adaptability of the platform and the domestic ability to modify mission systems allowed it to retain strategic relevance even as newer platforms took center stage. The gradual decommissioning of the Mirage fleet follows a structured transition plan. Aircraft with the lowest remaining fatigue hours are retired first. Airworthy aircraft are converted to unmanned configurations for live-fire training or used as instructional airframes. Valuable components, particularly engines, avionics modules, and sensors, are harvested and stored for use in other operational airframes. Pilots and technicians continue to transfer lessons learned to the development of tactics for newer platforms, while the infrastructure built for Mirage support is being retooled for newer airframes and locally manufactured systems. The enduring value of the Mirage 3 and Mirage 5 lies not only in their decades of service, but in the evolutionary role they played in developing indigenous aerospace support and tactical doctrine. They formed the cornerstone of Pakistan's ability to conduct standalone strike missions, sustain complex mission planning under sanctions, and deploy guided munitions under restrictive technological access regimes. Their role also had institutional implications. Flight testing, avionics validation, and aircrew doctrine matured around these aircraft. Capabilities such as radar masking, terrain following, and active countermeasure deployment were first field-tested on Mirage platforms before being migrated to later programs. The Mirage fleet essentially became a live laboratory for system integration and concept of operations development. These aircraft also helped seed the country's standoff strike capability. Before indigenous cruise missiles and autonomous aerial platforms were available, the Mirage 5 served as the foundational testbed for extended-range engagement scenarios. It shaped targeting doctrine, optimized missile delivery profiles, and trained generations of mission planners in complex engagement loops. Air superiority and strike roles gradually shifted to newer, lighter, and more sensor-fused platforms. However, the operational readiness and robustness of the Mirage fleet allowed Pakistan to maintain strategic depth, especially during periods when newer aircraft deliveries were delayed or unviable. Their presence in multiple squadrons ensured redundancy, and their proven ability to carry advanced payloads meant they were retained longer than originally intended. By supporting extended service life with continuous domestic enhancements, the Air Force avoided the need for abrupt platform replacement. It bought time to develop and absorb new platforms while preserving combat readiness. Over time, the roles of reconnaissance, radar jamming, and long-range missile delivery became highly specialized and were selectively assigned to the Mirage fleet due to its tested compatibility in large airframe community. Technological legacy is another key contribution. Experience with integrating targeting pods, helmet-mounted sights, and new data link standards fed into development paths for subsequent programs. Radar upgrades applied to the Mirage helped set parameters for airborne early warning and control systems. Lessons in airframe fatigue and wing load optimization influenced design criteria for newer aircraft now being developed or acquired. The aircraft played a diplomatic role as well. The ability to independently operate and sustain a high-performance fleet under difficult international conditions allowed Pakistan to negotiate from a stronger position in regional defense discussions. The aircraft's continued viability was a proof of concept for long-term fleet management through self-reliance, even when access to OEM upgrades was blocked. The Mirage also enabled inter-service integration. Air Force mission planners worked more closely with Strategic Command and missile forces due to the aircraft's role in nuclear delivery training. Mission rehearsal protocols, timing circuits, and system redundancies tested with Mirage aircraft became standards across the Air Force. In time, their place in active service will be ceremonial rather than operational. However, they have fulfilled far more than what was envisioned during their procurement. The delta wing silhouette of the Mirage remains one of the most iconic symbols of technological resilience, having survived operational, logistical, and geopolitical pressures for decades. Its continued flight beyond design limitations represents not just engineering ingenuity but institutional commitment to strategic capability development. Even as the last of these airframes are phased out, their impact continues in how Pakistan structures its defense industry, designs its mission planning protocols, and educates its airmen. The Mirage program has been a transformative experience for the entire force, one that helped the country bridge from dependency to autonomy in combat aviation. Its legacy is embedded not just in hangars or museums but in the systems, tactics, and doctrines of the current and future Air Force. Thanks for watching. Stay tuned for the upcoming videos.